Video can pick up the board nicely. All right, everyone fine 4-3? All right, problem number 1 says f of x equals 2x minus 2. 2x squared minus 2, excuse me, or minus x. All right, find the derivative. So f prime, remember that little prime means how to find the derivative. So I go 2 times 2, I get 4. Reduce, realize there's a 1 here, so this becomes minus 1. And then x to the 0 is just 1, so that becomes 1 times 1. Good to see you. Okay? So that's our derivative of that particular function. And then find the instantaneous rate of change. Okay? For b, the instantaneous rate of change, that's the slope at that point. So I'm going to take x equals negative 1, and I'm going to plug it into our derivative. So I'm going to get 4 times negative 1 minus 1, which is negative 4, minus 1, which is negative 5. So this is my slope at that exact point. Okay? And then it says find a point on the graph, at x equals negative 1. So I need to take that negative 1 and then plug it into the original, which is going to give me 2, negative 1 quantity squared, minus negative 1. So that's going to give me 2 times 1, which is 2, plus 1, which is 3. So that means the point negative 1 comma 3 is a point on the graph. Now, we can jump on Desmos and verify this pretty easily, and maybe we should just to be sure that we feel comfortable with what we found. So, does everyone have that written down? If so, I'm going to Desmos, getting rid of the statistics because I don't need it. So if I were to graph y equals 2x squared minus x, and then I were down here to say I want to plug in the point negative 1. What was the other value? Negative 1 comma what? 3. Thank you. Bold that. All right. So here's our graph. Here's our point. At exactly that point, at exactly this point, there is a line that is tangent. Means the line is a regular straight line. It will touch at exactly that point. If it touches exactly at that point, at exactly that point, the tangent line would have a slope of whatever our derivative at negative 1 was, and I believe we said it was negative 5. So, do you feel comfortable that the slope here, this line right here, does that appear to be a negative slope as it comes down? And is negative 5 a relatively steep slope coming down? Sure. So that's how you basically take a look at that first problem. Questions about that, my friends? Doing okay? May I move on? Number 2, for problems 2 and 3, what intervals are so-and-so? So I have basically, hello, great to see you, brother. It's good to see you. So we're on worksheet 4-3. So we have basically this kind of graph. And they say we have a point A right here, we have a point B right here, point C down here, point D right here, point E right here. And then they are saying from here to here, they're calling this like a distance of lowercase a. The distance from here to here is lowercase b. The distance from here to here is lowercase c. And the distance from here to here, that's supposed to be an e, is lowercase d. Okay, so I think I have this. Over what intervals a through d is it positive? Okay, so for letter A, where is our graph positive? What that means is my slope is positive. Okay, so B and I don't know what this point is. I would say it's positive from B. Okay? So it's positive here. And then it's also positive from C to E. Okay? Because I only had this, and then from C to E, it's also positive, meaning the slope would be increasing. Okay? And then over what interval is it negative? Let's change some colors. Let's go to a light pink. Pink's good. So for letter B, where is it negative? Negative means where the slope is negative. Okay? So it's negative from A to C. Okay? That means the slope would be going down. And then at what points A through E does the rate of change equal 0? Where this equals 0, where our slope, where is it 0? Meaning our slope is 0, which means it's a horizontal line. So at A, C, and E. So at your local mins and your local maxes, and exactly at that high point or low point, is where you would have a slope of 0. Okay? And then number 3 we do on the same graph. At what point does it change from positive to negative? So this is going positive to negative. It happens at A. And then from positive to negative, it also happens at E. So A and E is where it goes from a positive slope to a negative slope, and a positive slope to a negative slope. If I wanted negative to positive, it would go from A to C, and then E to whatever. I take it back. That's not anymore. And then negative to positive. So let's choose orange. And then so that's the answer to A. The answer to B, where does it go from negative to positive? Well, this is a negative slope here. This is a positive slope here. So that happens exactly at point C. So where it changes direction, going from up to down or down to up, is happening at the local maxes and local mins. At that fulcrum point where the slope would be 0 is where it's going to change from a positive to a negative or vice versa. Now it could go from positive to positive, meaning our graph could start coming up and have a point and then start coming up again. So that could take place, so we could look at that. Alright, we good so far? Any questions for me? Alright, let's take a look at number 4. See who was paying attention yesterday. What's the derivative of a number? 0. Okay? Number 5, I have this whole string of events. I have 10x to the 9th minus 5x to the 5th plus 7x to the 3rd plus 5x minus 6. If I wanted to find the derivative of this, what is the derivative of 10x to the 9th? 90x to the 8. What's the derivative of 5x to the 5th? 25x to the 4th. What's the derivative of 7x to the 3rd? 21x squared. What's the derivative of 5x? 5. Derivative of 6 is just 0, so you don't have to write it. So this is our derivative. Alright. I think the number 6 is kind of out, but this is what number 6's problem is. Alright, so let's take a look at this. This is where we have to use a little more creative thinking, because we have negative exponents. It's up to you if you want to make them positive exponents, but just make them negative for now. Alright, so the derivative of this first thing is going to be negative 5x to the negative 6. Dude, Stirrup, you just increased. Why did that increase? I heard it. I heard mumbling. What does it mean?
Tell them, honey.
So everyone gets where the negative 5 comes from, yes? So each time I do a derivative, I subtract 1 from this. So negative 5 minus 1 is negative 6. So what's the derivative of the next one? What's the derivative of that? Negative 8x raised to the? Negative 9. Again, I'm subtracting 1. And this is 3x to the first, so that just becomes negative 3. And then the 10 is plus 0, so we don't have to worry about it. Do you see where the things came from? So with the derivative, you take the exponent, you bring it down front. If there's already a number there, you multiply them together. Bring the sign as well. Subtract 1 from the exponent. That's why negative 5 became negative 6. That was why negative 8 became negative 9. Are we good? May I get to number 7? Good? Everyone happy? Anyone losing sleep over this class? I hope not. I think this is a pretty mellow class. At least I think it is. All right. I have not taught you something called the quotient rule at this point. Agree? Like, what's this quotient rule you speak of, Stirrup? You're right. I haven't taught it yet. All right. So a few things. I'm going to change f at x. I don't want to have things in the denominator. So if I move x to the 4th up, what happens to my exponent? If I move this up, what happens to the exponent? Who paid attention in Algebra 1? Does it become the same? Do I add like 7,000 to it? Do I change the sign? One of those answers is right.
You change the sign.
Yes. Okay, so 3 over x to the 4th is 3x to the negative 4. So what does this next one have to become then?
2x to the negative 3.
Good. All right. Ooh, here comes the trick question. I have the 3rd root. That's raised to the 1st. So I'm going to change this to 5x to the 1/3 power. So just remember this. If I have the square root and this is x, y, z, this becomes y to the z over x power. That's where the 1/3 came from. Did I do the derivative yet, or did I just algebraically modify my problem? You guys got quiet on me. Didn't mean to shock you. All right, here's my derivative. I don't see a prime on the green, so what's the derivative of the first one? Negative 12 x to the negative what?
3.
5. I subtract 1, so I have to subtract 1 from that. Okay, negative 4 minus 1 is negative 5. What's the derivative of this one? Negative 10 x to the negative 6. Very good. Okay, we have the F word up here, fractions. Oh, he almost said it. All right, 1/3 times 5 is 5/3. Agree? Then I get x. I have to go 1/3 minus 1 over 1, which is 3 over 3. 1 minus 3, so this is to the negative 2/3. This is my derivative. Now, should we clean it up? Yeah, in future math classes, maybe. Just do the algebra, so make it negative 12 over x to the 5th minus 10 over x to the 6th. And then 5 over 3 x to the 2/3. You could, but you can leave it dirty too. I don't mind it staying dirty. Okay? All right, I know I just kind of like threw a whole bunch at you. Is there anything you need me to go back to or re-explain? We good? You happy? Flip that page on over, please. All right, number 8 is a new idea. Okay? Number 8's a new idea. says we have this function, y equals 4x squared plus 3x. Okay? Letter A says find the slope of the tangent. So what does that mean I have to do to y? What do I have to do to the top equation? Do I divide everything by x? Do I take the derivative? Do I do the natural log of both sides? What do you want?
The derivative.
Derivative. If you were looking for a slope, that means you're doing a derivative. Okay, so y prime equals 8x to the first. Agree? Derivative of 3x is just 3, because that's to the first. So I get 3, and then x to the 0. X to the 0 is just 1. Alright, so this is my derivative. Okay? They're asking for what is my slope at x equals 2. So basically that's saying on the xy axis at 2, what is the slope? So I'm going to take this 2, I'm going to plug it in here. So I'm going to get 8 squared plus 3, which is 16 plus 3, which is 19. So what's my slope? That's right there. My slope is 19 over 1, or just 19. Okay? So I took the derivative, I plugged in the x value at that point, that finds me the slope at that exact point. Okay? 19 is a positive number. That's a pretty steep slope, meaning that slope of that linear equation would go up 19, right 1. Okay? Now, we want to find, this is newer, we want to find the equation as x goes through 2. This means I need to find a point. So I have 2 comma something. I'm going to plug the 2 back into my original problem. So I'm going to get 4, 2 squared plus 3 times 2. 2 squared is 4. 4 times 4 is 16. So I get 16 plus 6. So that gives me 2 comma 22. If I call this x1 and y1, I can use something called point slope from Algebra 1. Point slope is actually the most accepted way to write linear equations. The reason why we have y equals mx plus b is because Texas Instruments and Casio couldn't figure out in their operating system how to plug it in any other form as y equals. This is the form before calculators. This is what we had to do. Alright, so I'm going to plug in. I have y minus 22 equals slope 19, x minus 2. Okay, so this is the equation of the line that is tangent to our original function at 2. And there is a whole bunch of these that take place. Okay? I'm going to plug this into Desmos, and I'm going to zoom in and show you basically how it takes place. Ready? Alright, so let's clear this. Go y equals 4x squared plus 3x. So here is my graph. I know that I have a point of 2 comma 22. So I'm going to come up to this point. So here's my point 2 comma 22. And then I'm going to plug in my equation. And the nice thing is Desmos will allow us to plug this in. What did I say the slope was? 19, thank you. X minus 2. Oh, let's change that color. Orange. Alright. So, this orange line, the point of tangency is that dot right there. If I zoom in, it's probably not going to allow me to zoom in. This is good. It's really close to the parabola. In fact, we can't really see the rest of the parabola. Okay. here's our parabola. Alright, so the hard thing to see is we have some width to this line that doesn't really exist. So our parabola is the purple. This orange line is the line that is tangent at exactly that point. Can you see the rest of the parabola here? The purple and orange are together. This is the point of tangency. So when you do that, you take the derivative, you plug in the x value that's given, that finds you the slope. You plug in the x value that's given into the original, that will tell you the point. And then you use point slope in order to get your line of best fit, or your line that is tangent to your equation. Okay? Alright.
Wait, can you show me how you got the second equation?
Second one? Absolutely. Alright. So, you're good with the derivative all day long.
Yeah.
Are you okay finding the slope?
Yeah.
Okay? Once I find the slope, then I'm going to take my x value, the point that they want you at, the x value, you plug that into your original equation, and that's going to give you the point 2 comma 22. Okay? And then you're going to use the point slope equation, which is this, and you're going to plug your point that you found. So your slope goes for the m, 2 comma 22 plugs in. When I plug something in into point slope, the signs change. So this is a positive 22 here, it becomes a minus 22 here. This was a positive 2 here, it becomes a negative 2 here. You do not need to clean point slope up. Okay? Shame on your Algebra 1 teachers for forcing you to do it. Some of you had me for Algebra 1, shame on me. I'll take blame for that. Okay? So this is kind of a unique skill because you're finding the point of tangency at an exact value. Okay? So let's see if we can walk through number 9 together. Can I go off the screen? We good? Okay. So number 9 says y equals x to the third minus 3x squared plus 5. And then they say, hey, something's going to take place at x equals 1. Okay? Now we know we want to find the tangent line. So I could say this. I could say, let's find the point on our graph. Okay? So I'm going to take this, I'm going to plug it in here, here. So I'm going to get 1 to the third minus 3 times 1 to the second plus 5. 1 times 1 times 1 is 1. 1 times 1 is 1 times negative 3 plus 5. Do the math, that becomes negative 2. Negative 2 plus 5 is 3. So this means that 1 comma 3 is the point of tangency on our original line. Okay? Are we good so far with that? Have I found the derivative? Does anyone see y prime up there? We haven't found the derivative. So let's graph this equation on Desmos. So what was the point I had? 1 comma what?
3.
1 comma 3. So I'm going to turn both these graphs off. I have 1 comma 3. Okay? So that point is going to be important for us. Okay? So if I draw my original function, it's going to go right through that point. So my original function we said was x to the third minus 3x squared plus 5. Okay? So you see our dot right there? Everyone feel comfortable with that point right there? If I do this, notice, does our line go right through it? Now, I can change this. This is what the whole graph looks like. This is the point that we got because we plugged our original function into it. So there is a line with a negative slope that comes through and just kisses this right at this point. Now, it's going to have to cross it a second time because it change direction. There's something that we don't cover in this class, but it's called something called a point of inflection. A point of inflection is where I take all of the infinite amount of tangent lines and I actually flip from the outside of the line to the inside of the line. And it's something you have to do by taking the second derivative. We're not going to do it. But there is a line that is tangent to that point. And now I have to find the slope. So how do I find the slope with my equation here? What do I have to do to that equation to start getting a slope? Point slope, not yet. I have to find the derivative. Derivative of x to the third is? Derivative of x to the third?
2x squared.
Close. 3x squared. Bring the 3 down front, then reduce the exponent. Derivative of negative 3x squared? Negative 6x. Okay, so this is the derivative. How do I find the slope now? How do I find the slope when I have the derivative and I have an x value that's given? Anybody?
You plug the 1 in?
Yeah, 1 goes there and there. So I get 3, 1 squared, minus 6 times 1. That gives me 3 minus 6, which is negative 3. So this is my slope. So now someone said we need to go to point slope. Okay? This is x1, this is y1, this is my slope. Y minus y1 equals m times x minus x1. So I'm going to get y minus 3, slope of negative 3, x minus 1. This is my point slope linear equation that will have that point of tangency. If I went ahead and graph this on Desmos, I'm going to get y minus 3 and the slope of negative 3 and minus 1. Okay. So, I don't have this equation on yet. This is my equation that's going to go kiss that right here. And if I do this, notice the orange line. It feeds on top of it, but if we zoom out, when we zoom out, yes, this actually, so in theory, this becomes something called the secant line, it looks like. It actually like kind of crosses through there. It's kind of hard to see. I mean, zooming in a whole bunch, might not see it as clearly. But the purple graph exists above and below. This is the line that is tangent at this exact point. That equation, y minus 3 equals negative 3 x minus 1. That is the equation which is tangent to the purple, to the original equation, through the point 1, 3. Okay? Alright, so now I've fed you a whole lot more. Would you try, see if you can get a good try on 10 and 11, doing the same concepts we've been doing. Okay, see if you can figure those out. Okay? Where are we at? Tomorrow's Wednesday. We're good. We're good, I think. Try 10 and 11. See if you can figure those out for tomorrow, and I'll mark those off. If you give me an honest try tomorrow, I'll make sure I put points in for you on that. Deal?
I think you can